Okay, so in today's lab, we calculated the initial velocity of a Nerf bullet using inelastic collision calculations. The results showed that that initial velocity was right around 18 meters per second.
So we have a setup like this, a plastic bottle filled with paper towels and has some mass. And so a Nerf bullet is being shot with some mass and some velocity into the bottle. And so after the bullet goes into the bottle, then this pulley will swing up with some velocity and be displaced some height from where it originally was. Now to calculate the initial velocity of the bullet, what we need to do is use the conservation of momentum equation first for elastic collisions. And so we're trying to find V1, and we know M1 and we know M2 because we've weighed the things, but we don't know is V2, and that is the velocity as the dart moves into the bottle. So to find V2, we use the conservation of energy equation. So we know now H, we know G, we know M2, we know M1, and then we can solve for V2. So we can plug this V2 back into here and then solve for V1 and get our final answer.
Okay, this is the ballistic pendulum calculations. So we started off with the mass of the bullet, or the mass of the bottle at 25.03 grams. And this was, 25.03 grams. And then we have the mass of the bullet, was called L, equals 1 gram. Then we have starting height, initial equals 0.1 plus or minus 0.005, 2 zeros not there, and the height H final is 0.125 plus or minus 0.005 as well. So we start off by finding the kinetic energy of the equation, or kinetic energy of the system after the initial collision, using the generic kinetic energy equation, but we did it with both M1 plus M2, half mv squared, v prime squared, right, after the collision, equals the potential energy, which is the mass 1 plus mass 2 times gravity times height. This is the height of the difference. So we plug in our numbers here. We have half, and these cancel out. These are both multiplied. Half v prime squared equals 9.81 times the height difference, which is 0.125 minus 0.1. And we simplify this out, and this will give us a v prime initial, or v prime of 0.7 meters per second. So then we have our final velocity of the equation, and we need to plug this into the momentum equation to find the initial velocity of the bullet. So this is m1 v1 plus m2 v2 equals m1 plus m2 v prime. We know that the velocity of the bottle is 0, so we'll cancel this out. And we know the mass of the bullet is 1, so this is equal to v prime, or equal to v2. So v of the bullet equals 26.03, which is the combination of two masses, times v prime. V prime is 0.7. This gives us our final velocity of the bullet at 18.23 meters per second. Now we have to calculate our error. And we can start by finding the min and the max of the equation, but we know that the v of the bullet is equal to v prime times mass squared times the mass, and v prime is equal to this. So we have the ready? To calculate our error, we know that the equation is basically v prime of the collision times the combination of the masses, because we can simplify this, right? So we have 26.03 times v prime, right? So our v prime, however, would be the square root of 2 times g times the difference in height, right? So we have to find our min height, our min difference basically, which would be v prime equals 2 times 9.81, and we plug in our minimum top height, which would be height final minus that, so 0.12, and then we have to do minus our final, our h initial, but our maximum h initial, so that would be 0.105. And if we solve this and we multiply this, and then we do v prime times 26.03, we get a we get our final, we get our final minimum value to equal 14.056 meters per second. And we find for our max, which we find v prime to equal square root of 2 times 9.81 times the maximum height, which would be 0.13, minus the minimum height, 0.095, and this again multiplied by v prime 26.03 equals 21.34 meters per second.
From the height that the bottle made it to, we can calculate that the velocity of the bullet is 18.221 plus or minus 3.642 meters per second, obtained by using the change in height after the bullet was shot into the bottle. Three of our main possible sources of error are the camera used, the angle of the camera, and the meter stick. Measurements taken by the meter stick are accurate only down to the millimeter, and the camera used could only record the 240 frames per second. Therefore, it might not have captured the absolute total height. Furthermore, there is the issue of camera angle, where if the camera used is above or below the bottle, it will record a different value than the true total height. If the experiment were to be repeated, in order for the most possible accuracy, it is advisable that the camera be fixed at an angle set for the total height, and the camera be one that can record at a much higher frames per second.